Once again, thank you everyone. So we're going to start today's session. So in today, the session will be for approximately around 2 hours. For the first 1.5 hour, I'm going to take the session, and for last 30 minutes or 45 minutes, we'll have question and answer session. So first, I'm going to start the demo for SAP HANA. So first of all, what is HANA? HANA stands for High Performance Analytic Appliance. So when we say high performance analytic appliance, what does this mean? I'll take a very simple example to demonstrate what is high performance. Let us take a table. Let us take a table with 4 columns. So we have a table with 4 columns. So we have customer column, product, amount, and quantity. And the volume of data that we have in this table is more than 2 trillion records. So it's more than 2 trillion records in the table. And we're asking very, very simple questions on this table. For example, I'm asking a question like, who are my top 5 customers? Table with 4 columns containing 2 trillion records, and we're requesting only 5 records to the top. So in order to answer this question, in order to answer who are my top 5 customers, it has to scan the entire 2 trillion records and get the result, sort and give back to the user. In order to get this answer, if this table, if this data, and if this question, I'm asking on an MS SQL DB. If I'm asking on an MS SQL DB, it takes more than 8 hours to answer this question. It takes more than 8 hours. Now, when I ask the same question on HANA, it takes less than 6 seconds. So on an MS SQL, it takes 8 hours. In HANA, it takes less than 6 seconds. Now, what is the reason that HANA takes 6 seconds, whereas other databases take more than 8 hours? What is the reason behind it? Let us see this. So there are primarily 3 reasons. First one, HANA is a in-memory database. Second, it's a column-oriented DB. Third, it does massively parallel processing of data. Now, why due to these 3 reasons HANA is extremely high performance? Let us try to understand the first one. What is in-memory database? Now we know a database is a collection of tables in memory. For example, Let us take a computer. In a computer, there are main three parts. There are three main parts. One is the CPU, the second one is RAM, and the third one is disk. The first one is CPU, second one RAM, and third one is disk. Databases like MS SQL, the primary way to store data for them is always on disk. So this is the place where MS SQL primarily stores data. But the same table if you want to store in HANA, the primary way for HANA to store data is in memory. Now, why did SAP thought to separate this content from a container which is made up of an iron plate and put the same content into a different container which is made up of transistors and capacitors? Now, in-memory database is nothing but database collection of tables in memory. So for HANA, the primary way to store data is always in memory. So this is where HANA stores data. Now why SAP wanted to keep here is because of two reasons. The first one being RAM is faster in processing data. RAM, by the nature of storing data in transistors and capacitors, it is 100,000 times faster than processing data on disk. So first of all, RAM is faster to process data. And the second reason is when I ask a question, to get answer for this question, it goes to the CPU and to the memory and to the disk. From disk, it gets the answer back to memory and to the CPU and to the front end. Now, when you store data in memory, it goes to CPU, goes to memory, back to CPU, and back to the front end. Now, in here, we're keeping data close to the CPU. Now, is it better to go drink water from a kitchen or take a flight, go to a different place, drink and come back? Always, kitchen is a better place. So, the same way, whenever we keep data close to the CPU, it can be accessed faster to the front end. So, why in-memory databases have extremely high performance is because of RAM is faster to process data. That is the first reason. The second reason is data is kept close to the CPU. In other databases, data is kept on disk. Disk is a bottleneck. The disk is associated with the speed. So disk has a speed associated with it. It has 7,200 RPM. So usually if you take normal disks, the fast at which they can get the data from disk is 7,200 RPM. So that's the bottleneck. That's why SAP wanted to keep it in memory, and memory is kept close to the CPU. It can be faster to access to the front end. Coming to the second one, what are column-oriented databases? And why column-oriented DBs have extremely high performance? What is the reason behind it? So let us see this. What is a column-oriented DB? Now in SAP, traditionally SAP uses traditional RDBMS. So traditionally, the way they store data in row versus, so let me copy this table. I just draw the table here. Just copy this table. So you have the same table in row and column. So here we have in row, and here we store data in column. So traditionally, if you see the way the data is stored in row, let's say for example, I insert one row C001, M001, amount is 100 and quantity is 10. I insert one row for 4 columns. I insert one row here for 4 columns. Now the same row, it goes in the backend, it saves in a file. The table stores data in a file. So the way it stores data in a file is something like this. So when you insert a row, now the row is inserted in a file. So let us insert one more row. So C002, M002, 200 and 20. I'm inserting second row again. So let's copy this row as well. Now, if I ask a question now, who is my top customer? So in order to get answer for this question, what system does is, it'll start from C001, M01, 110, C02, M02, 220, and gets back the answer saying that, okay, the top customer is C002 is because the amount is 200. Now, if I ask the same question in columnar databases, I'll just copy this data into column. If you ask the same question in column, so in row, all the data is stored in a single file. In columnar databases, each column stores data in a different file. So 4 columns, we have 4 files. So file 1, file 2, file 3, and file 4. So this is customer column. This is product. This is amount, and this is quantity. So I'll store this data C001, C002, M001, M002. So each column is storing these values 100, 200, 10, and 20. So in here, when I ask a question, to get the answer, it has to scan all the columns. You see, it's trying to scan the entire table. So in order to get 2 values to get answer, it has to scan the entire 8 values. But in column, what it does is, because each column is storing in a separate file, each column's data is stored in a separate file. If I ask a question, who are my top customers? It goes to the customer column. It scans the data in the customer. It skips product because I'm not asking the question on product. It skips product. It goes to the amount. It skips quantity. So what is the difference between row and column is, in row, it has to scan the entire table to get the question answered. But in column, it only goes to those specific columns that are asked in the question. The rest of the columns, it skips. So the advantage is it takes shortcut to data in column. It takes shortcut to data. In here, it has to scan the entire table. So why column-oriented databases are faster is because in SAP, if we see in SAP, simple tables like KNA1, which stores customer-related data, MARA, which stores material-related data, or any financial tables like BSEG. These tables are more than 100, 150, 200 columns. If a table has more than a simple customer table has more than 150 columns, and then I'm trying to ask only 4 or 5 columns from the table. In row, it will try to scan the entire table. In column, it only goes to those 4 columns and gets the data. Normally, when we ask question, we would not require to see the entire data of a table because it's very confusing to analyze the entire table's data. So I only ask questions that I may require to analyze. In column, it only goes to those columns. In row, it has to scan the entire table. So that's why column-oriented databases have extremely high performance because SAP tables are very, very large. In order to have performance on the table, I only select required columns. That is the reason we store data in a columnar fashion. So just to conclude, the difference is in row, it scans the entire table. In column, it only goes to those required columns. So participants who have joined later, I just started to discuss why HANA is high performance is because of 3 reasons. One is the in-memory DB, the second one columnar databases. In in-memory databases, the primary way to store data is in memory. So whenever we ask a question, it directly goes to memory, gets data. Data is kept close to the CPU. The second one is RAM is faster in processing data. That's why in-memory databases have extremely high performance. What are column-oriented DBs? What is the difference between row and a column? In row, whenever we ask a question, it has to scan the entire table. In column, it only scans those relevant columns to get the query answered faster. Third one, what is massively parallel processing of data? What is massively parallel processing of data? Now in massively parallel processing of data, I'll take a very simple example to demonstrate this. Suppose say you have a building which consists of 5 floors. So you have a building which consists of 5 floors. And you ask a person to paint the entire building. We ask one person to paint the entire building. So what this person does is he goes to the first floor, paints second, third, fourth, and fifth. So in here we are doing sequential processing. So every day he paints one floor. For 5 floors, it takes 5 days. Now, if we deploy 5 people doing the same work, if we deploy 5 people doing the same work, now first of all, they will try to distribute the work among themselves. So this person will paint here. So first they will distribute the work. They will distribute. They will process the work. They'll process. So each person paints his own floor. And finally, the work is assembled. Once the work is completed, the work is assembled and tells to the owner that work is completed in one day. The more the resources we deploy, the less time it takes to process the work. So one person does in 5 days and 5 persons does in one day. The second one is massively parallel processing. So how does this apply to programs in computers? Now, if you see, we have CPU. So we have dual core CPU, quad core, 8 core, 16, 32, 64. So we have CPUs which have multiple cores in it. So each CPU has multiple cores. So core 1, core 2, core 3 and core 4. So this is a quad core CPU. One CPU has multiple cores. So each core of a CPU in HANA can process 30 billion scans per second per core. Sorry, it is not 30, it is 3.2. It is 3.2 billion scans. It is 3.2 billion scans per second per core, and it is 30 million aggregations per second per core. So the aggregation speed is 30 million and the scan speed is 3.2 billion scans. Now in an example, if I want to scan a table which has 30 billion records, for example, if one CPU tried to process the entire 30 billion records, approximately it takes around 10 seconds. Now if you have 10 CPUs performing the same work, you have 10 cores inside a CPU. A core is nothing but a CPU inside a CPU. So this is also called a CPU, but we call it as a core because it's inside a CPU. In order to differentiate a core and a CPU, we call core, which is inside the CPU. So basically, each core can process 3.2 billion scan and 30 million aggregations. So if you have 30 billion records to process by one core, it takes 10 seconds. If the same work is done by 10 cores, it takes 1 second. So in HANA, when you have complex programs, the programs are broken down into smaller subsets. Each subset of a program is assigned to different cores of a CPU. It processes the program, assemble the result, and give back to the user. Same way, when you have large tables or programs, they're basically divided into small parts. Each part is individually processed, assembled, and give back to the user. So massively parallel processing has extremely high performance. So why HANA high performance? 3 reasons. In-memory DB, data kept close to CPU, RAM is faster to process data. Columnar databases doesn't have to scan the entire table, only scans required columns. Parallel processing, complex programs are broken down into smaller subsets, and each subset of a program is assigned to different cores of a CPU, and each CPU process, assemble, and give back the result. So how fast each CPU can process 3.2 billion scans and 30 million aggregations. So until now, we're only discussing about what is HANA and what HANA can do for us. Now, when a business wants to implement HANA, what is our role? The most important here is, until now we're only seeing what HANA can do in general, but what we have to do with HANA. So we are called as SAP HANA application consultants. So we are known as SAP HANA. So basically, we'll be known as SAP HANA application consultant. Or also you can apply for a role called S4 HANA consultant. SAP HANA, so both the roles we can apply. So after completion of the course, you can apply for both S4 HANA consultant or SAP HANA application consultant. So I'm going to cover both the parts in this course. So as this role, so what is our activities under this role? There are primarily three activities. One is known as data modeling. The second one is data reporting and data provisioning of data. So as a HANA application consultant or S4 HANA consultant, we're primarily responsible to do three things: data modeling, data reporting, and data provisioning. So there are two scenarios over here. So we'll discuss about three of them. One is called as a sidecar scenario. And the second one is known as main car. Now, what is sidecar and what is main car? Let us take a simple example. Now, let's say the company has already implemented the solution from SAP. So they're already using an OLTP system, online transaction processing system, which is ECC. You can have ECC or you can have CRM or you have supply chain management, SCM. So any of the business suite of applications you're already running for a certain period of time, you're running your business operations in the system. Now these systems that you're already running is on the database, which is MS SQL, for example. So you can have other databases as well. I'm taking this example, you're running your existing applications on MS SQL. Now today, we wanted to implement HANA. We want to take advantage of Hana. So we bought a new solution called Hana. So sidecar means we have our existing solutions. Parallelly, we are running a new solution over here. We have, this is the existing solution and this is the new solution. Now, why do you want to implement Hana when you have an existing solution? The reason again, performance. The first thing comes to my mind is high performance. Now, what is the difference? Difference is the way they store data in here, it's on disk. Here it is storing on disk. The primary way to store data is in RAM, in memory. Here it stores data in row. Here we are storing data in column. Here we are doing sequential processing. Here we are doing parallel processing. So that is the reason whatever the data that I have in these systems, I would like to move to Hana to take advantages of this in-memory column and parallel processing. So in order to move data as and when required, to move in batch or to move data in real time. For example, whenever a sales order is created, immediately the sales order should be available in Hana, immediately, with a blink of an eye. We can use data provisioning methods. We can have data provisioning methods like to provision data is to move data from one system, which is the source system. What is source system? Source system is a system where data is originated, and this Hana is the target system. So we want to move data to Hana from the source system. So we use data provisioning methods like SLT. SLT stands for SAP Landscape Transformation, to move data from one system to a different system. The second one, BODS, Business Objects Data Services. Third one, DXC, Direct Extractor Connection. Direct Extractor Connection, Business Objects Data Services, SAP Landscape Transformation, Smart Data Access. Smart Data Access. So SLT, SAP Landscape Transformation, Business Objects Data Services, Direct Extractor Connection, and Smart Data Access. So these are the different ways that we can move data. So why do we want to move, performance? Disk versus memory, row versus column, sequential versus parallel. So data provisioning is nothing but moving of data. But how do you want to move? There are different ways to move with different tools. SLT is to move data in real time. So what is real time? Real time means, as we just discussed, whenever you make an insert or you make an update to an existing sales order, or we delete an existing sales order, any insert, update, and delete we do on the source system, immediately with a blink of an eye, it is available in Hana. SLT. SLT for real-time data transfer. It's for real-time transfer of data. SAP Landscape Transfer is used to transfer data in real time. BODS, Business Objects Data Services. BODS is known as ETL. It's known as an ETL tool. Extract, transform, and load. So when we say ETL, what does this mean? So a BODS can connect to SAP as well as non-SAP systems. Like MS SQL is a non-SAP system. You can connect to non-SAP system or SAP systems. You can extract data, transform. Transformation means we can apply business rules. Like you want to merge data from two different tables. We would like to write a condition. So you can apply business rules to transform data and finally load to HANA. You can do data integration and data cleansing. So BODS is a batch processing. It does processing in batch and rich in transformation. It is rich in transforming data. So what is the primary difference between SLT and BODS is SLT is real time. So whenever you create a sales order, immediately it is available in HANA. But BODS cannot bring data in such manner. When you create a sales order today, you need to schedule a time. Okay, trigger a job at daily at 8 a.m. in the morning. Trigger a job 8 a.m. in the morning. This job will go here. It fetch data and update to HANA. So that's why we call it as batch. Batch means scheduled interval of time, but not as and when data is inserted, it cannot get data to HANA. So that is SLT. So SLT is used for real-time data transfer, BODS for batch processing. I'll tell you a very simple example for this. For example, I would like to know, so if this is the requirement, I would like to know what is the stock on the shop floor. A very simple example. If I want to know the current status of the stock until this second, what is my stock available on the shop floor? So do I have to go for SLT or BODS? The current status is SLT because I can see data in real time. But BODS, because of the batch, so morning it could have bought data. In order to see the current status, again I have to wait until tomorrow morning. Then what are the use cases for BODS? The use case is, let us take for HR. In HR, we have payroll. In payroll, let's say we capture data related to salaries of an employee. So salaries of the employee is going to change on a daily basis? Probably no, because employee receives salary by week or let's say for 15 days or 30 days. So data is not changing as frequently because the way it stores data, the way the data gets refreshed is based on weekly or based on 15 days or monthly. So only during that time I execute these jobs because there is no daily update of data. It is on weekly or monthly. So for such use cases where data is not changing frequently, I can go for BODS. For cases like inventory management, where you want to see the current position or the current status of data, then we can go for real time. Third one, DXC, which is known as direct extractor connection, a direct extractor connection. So what is the use case for DXC? Now usually if you see, we used to have systems like SAP systems where these systems are optimized for writing of data. You can write data very faster into these systems. These systems are not optimized for reading of data. These systems are optimized for writing of data. So what we used to do is we take a copy of data from this system. We'll copy this data into a different system. And this system is known as BW, Business Warehouse. So it's an enterprise data warehousing solution. It's an enterprise data warehousing solution. So we keep data in this system. So these systems are optimized for these systems are optimized for writes, and these systems are optimized for reads. So I get a copy, I store in BW, and business will reading data from this system. Business will read data from these systems. So this is the way we were working to have faster reporting. So now by using DXC, what I can do now, by using DXC, whatever the data that is going to the BW and the question I'm asking on the BW system to get the answer from this data, I can design the same questions in HANA. I can design the questions that you design in BW. I can design the same questions in HANA. So to get the answer, I need to have data. So what DXC can do is, it can bypass this data. So whatever the data that is going here, it can bypass a direct extractor connection. And directly you can connect, you can get the data to HANA. So DXC enables us to get data or to bypass data that is going to BW to get into HANA. So DXC, a specific use case is only when you have BW. Only when you have BW, you can bypass existing BW, get data to HANA, and get this questions answered on HANA itself, rather than designing the question in BW. Again, it is high performance. And the last one is smart data access. Smart data access. So when do we use smart data access? Smart data access is to connect to non-SAP system. Especially you have different non-SAP systems like MS SQL, IBM DB2, DB4. You have Hadoop to process semi-structured or unstructured data. So when you want to get data from non-SAP systems, which are non-SAP systems, we can use smart data access. So using a smart data access, we can connect to a non-SAP system by using ODBC drivers, by using a driver called ODBC, Open Database Connect. You can connect to non-SAP and the same data you can get to HANA. So this is what a data provisioning we have to do. In the data provisioning part, SLT for real-time data transfer, BODS, Business Objects Data Services, to extract, transform, and load to HANA, DXC, whatever the data that goes to BW, bypass and get to HANA, and smart data access is to connect to a non-SAP system. We can connect to different non-SAP systems and get data to SAP HANA. So that is on the provisioning side. Now, once we have this data in HANA, what next? So once we have this, so by using different provisioning methods, let's say we got all the relevant data based on the business requirement. So you have different tables in HANA now. You got from different provisioning methods. Now in HANA, we do something called data modeling. Now what is data modeling? Data modeling is nothing but defining, in very simple terms, defining relationship between tables. So you can create data models in HANA. Now if you see, as a HANA consultant or a S4 HANA consultant, most of our time, 60% of the time, we're going to perform data modeling. And data reporting is other 20%, and data provisioning is another 20%. So provisioning of data, presenting, so data reporting is nothing but presentation of data, UI, and data reporting is UI, data provisioning is to move data, data modeling, we do it directly in HANA itself. So data modeling, what is data modeling? It's nothing but defining relationship between tables. So once we define this relationships between tables, it creates a model. So these data models, I can expose them to business. So business will start consuming these data models. So business will start consuming these data models using different tools like BOBI, business objects, business intelligence, or non-SAP tools. So you have different non-SAP tools like Tableau is one tool, TIBCO Spotfire, IBM Cognos. All are different non-SAP. Also, you have SAP tools like BOBI, Business Objects, Business Intelligence. So again, in BOBI, you have different set of tools based on different business users, how they consume data. So every user wants to consume data in different way. So you have a tool called Lumira. So Lumira is also known as Cloud for Analytics. It's also known as Cloud for Analytics. So it's a cloud-based analytics tool. You can consume data in cloud. So this is mainly for self-service BI. Self-service means, so no one will design report for business. So business can ask any question. They can design their own reports. So everything they can do on their own. Self-service. It's very easy tool to use. Very user-friendly. So whatever the questions they want to ask, they don't have to come back to technical consultant. They don't have to come back to a consultant. They can design their own reports in a very high visualization manner, and that too in cloud. So advantage is rich in visualization, very simple interface to use, self-service BI, and it is on cloud. So this is nothing but the UI, the presentation of data. So we move data from these different methods. Data comes to HANA. We create data models in HANA. And we expose these data models to BOBI in different ways the business can consume data. One is Lumira. The second one is analysis for Office. analysis for Office. Like you can consume data in Excel or in PowerPoint. So when business want to do any PowerPoint presentation or they want to consume data in Excel, most of the business users are very comfortable working on Excel because they used to be working for last 10 or 20 years on Excel. It's anything that is similar to Excel, like spreadsheets. So still they don't want to move away from the traditional thinking. So that's why SAP has introduced a tool called Analysis for Office, where they can expose data from HANA in Excel and business can consume data on Excel and also in PowerPoint. And then you have Design Studio. Design Studio is where you can consume data in mobile, like Android mobile, iPhone. You can consume data in iPad. Design Studio. Crystal Reports Enterprise. Crystal Reports Enterprise. So Crystal Reports is to consume data for highly formatted reports. High formatting of a report you can do in Crystal Reports Enterprise. Analysis for OLAP. So these are the different UI. So these are the different UIs that you can use to consume data. So this is the UI part to consume data, and this is data modeling, and this is data provisioning. So this is sidecar scenario. So you can have an existing solution, parallelly you can run a new solution in HANA. So data modeling is done inside HANA. Data reporting, you can use different reporting tools, and data provisioning. So these are the different tools you can provision data. Now what is main car? So let us see what is main car scenario. In a main car, you'll have business suite on HANA, which is known as S4H on HANA. Suite on HANA. Or the new system S4 HANA. S4 system on HANA. So in a main car, you still have the presentation of data, which is the data reporting. Not only in data reporting, but also you can consume data in Fury or UI5. You can consume data in Fury or UI5. So these are the new UIs from SAP, Fury and UI5. So using that, you can connect to HANA. So this is the presentation of data in S4 or in Suite on HANA. Both on HANA you can. So HANA has an inbuilt application layer. Inside HANA, you have an application layer called Access Engine. Access Engine. So usually application server is outside HANA. So usually it is kept outside, but now it is inside HANA, which is known as Access Engine. So this is a lightweight web application server. So using this application server, you can expose data in new ways. In new ways, you can expose to Fury, you can expose to UI5, new ways of integration. So you can have data models in HANA itself. So you have data models here. So what is not there over here is, you see when suit is on HANA or S4 is on HANA, we don't have to move data. So in the first case, what are we doing here? So ECC system is over here. We are moving data to HANA over here. But in here, ECC itself is on HANA, or S4, which is simplified version of ECC, is on HANA itself. So suit on HANA in the sense you have different applications like ECC, CRM, SRM, PLM. All these different systems are sitting on HANA. And S4 is a simplified version of ECC. S4 stands for, S stands for simple, and 4 stands for fourth generation software from SAP. So S4 mainly discuss about the simplification of business processes, the way they store data, the way they process data, the way we present data, the way we operate our IT infrastructure in a more simplified way. So in terms of presenting, we use new ways to consume data with Fury, with integration with other BOBI reporting tools, third-party reporting tools. Usually these systems are on-premise, but S4 HANA is a system which supports for cloud. You can have on-premise model as well as cloud version for S4. So both these models are supported. So as a HANA consultant or as a S4 HANA consultant, on the main card scenario, we will be working on suit on HANA, S4 HANA, or on the sidecar scenario. So any of these landscapes we will be working. So what are we going to basically cover in this course? So in HANA, first we're going to start with modeling in SAP HANA. So in modeling, we're going to start with what is attribute views. Attribute views are mainly dealing with master data. They deal with master data. Analytic views, they deal with transaction data. Calculation views deal with both master and transaction data. Creation of information views. So information views are nothing but attribute, analytic, and calculation views. And what are the best practices to use these data models? Performance optimization. How to tweak the performance using visualize plan. Currency conversions. How to convert from one currency to a different currency based on the exchange rates. Variables. Variables are input boxes where user can enter data. So if they want to see data for company code, we can create a variable for company code and see only those company codes. Metadata export. Metadata import, export, import models. So this is mainly dealing with transporting of data models. We transport, after finishing the development, we transport to quality. We perform UAT and then finally transport to production. So how we are going to transport, we're going to see in export and import data models. SQL script, CE functions and procedures. So if we see HANA course, HANA is based on model to code. It means that we're not going to write the code, we only generate data models. So once these data models are generated, system writes the code. If you see ABAP, in ABAP we have to write code, then system generates the model. It's opposite of ABAP. So we generate model, system writes the code. So that's why HANA is known as model to code. But we still have to write code for 5 to 10%, which is an SQL script, C functions and procedures. So this is very simple, which is in SQL. SQL is just like English language. It is very simple to write. So using SQL script, it uses a scripting language called SQL script. C functions are nothing but calculation engine functions. You have predefined functions to use, and a procedure is just like a function module in SAP. Procedure executes inside a database. So when we execute a logic inside a database, data and logic is kept together. It is faster. Usually logic is in the application layer and data in the database layer. So both have to communicate to each other. They're kept far. So using a procedure, we can keep data and logic together, and hence it is faster. Hierarchies. Hierarchy is nothing but defining of parent and child relationships. You can create a time hierarchy in where you can show what is my revenue based on a year, and then you can drill down to quarter, month, week. So you can create hierarchies, restricted measures, calculated measures. You can create formulae. You can concatenate two columns. You can restrict based on a company code to certain measure. Different types of joins in HANA. So when you're joining these tables together, when we are joining these tables together, we have to define join type. What are the different join types? What are the different types of join? Like referential join, text join, inner join, right outer join. So these are nothing but the conditions. So when you do data modeling, we have to define these join types. Auto documentation. This is for documentation. Once we complete our build phase, we can generate this documentation. Data reporting. Data reporting mainly focus on the presentation of data, how you would like to present data. Like we see there are different tools like BOBI, Excel, Web Intelligence, Design Studio, Lumira, Analysis for Office, Analysis for OLAP, Explorer, Crystal Reports Enterprise. All these are different reporting tools on how we can consume data. A business can consume data. So this is on the front end part, the UI part. Provisioning. In the provisioning, nothing but the data provisioning, DXC, SLT, BODS, Smart Data Access. So all this will be covered end to end. Administration in HANA. So we will see how to install HANA. So these topics are mostly for senior management, like for solution architects, senior consultants. So usually we don't do this, but this is just good to know for the consultant, and it will be very useful for solution architects. So especially how to create these systems, how to do system sizing of SAP HANA system, how to take backup, disaster recovery. So all the administrative topics in HANA, administration and performance optimization. And then user management. In user management, how to manage users, how to manage roles, how to give authorization for user based on the user matrix. So what user should be able to see what data, what kind of privileges they have. So all this we discuss in user management security. And then there are accelerators. So in here we're going to discuss two end-to-end projects. One is based on sales and distribution, and the second one is based on COPA, controlling profitability analysis. So right from project preparation, preparing of blueprint, preparing of technical specifications, and designing low-level design documents, high-level design documents, how to transport unit test, user acceptance test, volume testing, preparing for go live, production support, continuous activities, maintaining of system, issue resolution. All this we're going to see in the project. So project is actually part of the training itself, right from the first session. So tomorrow also we have the session. So tomorrow we are going to introduce to how we can access various systems in our landscape. So we can see main car scenarios, sidecar scenarios, ECC on HANA, suite on HANA, S4 on HANA. All these systems, how they're integrated to each other. So we'll see a live demo on the system tomorrow. So today is only an introduction session. It's mainly what is HANA and what we are going to deliver as a part of this course. So tomorrow we will see how the systems are integrated with each other. So from next week, we'll conduct our first session. So right from the first session, we will conduct the course. So I will conduct the course in such a manner that how we actually work on the project, right from this scratch, how we get the requirement, how we convert to technical specification, how we build low-level design documents. So right from the first session, we'll start the project. So usually we take projects at the end of the session, but I'll take from the during the session itself, so that we can correlate the theoretical session with practical experience on the project. So two projects, one is COPA and sales and distribution, controlling profitability analysis, COPA, controlling profitability analysis and sales and distribution. We'll see end-to-end scenarios. And then how BW powered by HANA and how HANA can leverage the capabilities of BW. So that's on BW on HANA. So when you have BW system on HANA, what are the various options that you have? What is in-memory cubes, DSOs, transient providers? Whatever data models we design in HANA, we can expose to BW. Or whatever models we design in BW, we can import to HANA. So mixed scenarios, how to mix and match various scenarios, how both of them complement each other in business. That is on BW and HANA. And then S4 HANA. S4 HANA mainly talks about what are the various activities as a S4 HANA consultant in terms of data modeling, in terms of provisioning, and in terms of configuration, in terms of presentation of data. First is introduction to S4 HANA. We'll see exercises on simple finance. What is simple finance? How a simple finance solution is designed. Introduction to simple finance and simple logistics. So there's a new solution called simple logistics. Introduction to simple logistics. So migrating of code, predefined data models that SAP has given. For simple finance and for simple logistics, SAP has given predefined models called SAP Hana Live. SAP Hana Live are nothing but predefined models that SAP has given. We can consume those data models. We can tweak, how to enhance based on the business requirement. How to move from on-premise to cloud. How to convert to a cloud. So if you're an on-premise customer, how to convert to a cloud customer. Introduction to SAP Fiori. Introduction to various apps in Fiori. All this we see in the